Day 14 of 90, and today we build something you'll actually use, a to-do list that survives a refresh. Here's why this matters: most junior devs can follow a tutorial, but the second you ask them to wire up real persistence, they freeze. When do you read from local storage? How do you keep memory and the DOM in sync? Stick around, because by the end you'll understand the one mental model that makes state bugs disappear. Let me break a naive to-do app live. I type buy milk, hit add, it shows up. I add walk dog, great. Now watch, I refresh the page. Everything's gone. The list is empty. Why? Because those todos only ever lived in the DOM. The browser threw the whole page away on reload and there was no record anywhere. That's the problem we're solving. We need data that outlives the page. Enter the serialize contract. Local storage only stores strings, so you cannot hand it an array directly. On write, you call json.stringify before saving, localStorage.setItem, todos, json.stringify, todos. On read, you reverse it with json.parse. Picture the data flow: your array lives in memory, you serialize it down into local storage as text, and on reload you deserialize it back up into memory. Memory to storage on save, storage to memory on load. Same shape, just a string in the middle. Now the first load trap. On a brand new browser, localStorage.getItem, todos, returns null, and json.parse, null, blows up your app before it even renders. The fix is a fallback: const todos equals json.parse, localStorage.getItem, todos. If nothing's stored, you parse an empty array string instead. Read that left to right, get the item, fall back to the string bracket, then parse. One line, and your app boots clean every single time, empty or full. Here's the idea that changes everything: your array is the app. The DOM is just a printout. So we keep one source of truth array in memory, and we write a single render function whose only job is to draw that array. Render wipes the container's inner HTML and rebuilds the list from todos. Adding an item becomes 3 steps: add to do, pushes to the array, calls save, to persist, then calls render, to repaint. State changes, we save, we redraw. You never read a value back out of the DOM is downstream, never the source. Now the bug that bites everyone. The naive instinct is to attach an add event listener to each to-do item as you create it. It works until render wipes inner HTML. Those elements are destroyed, their listeners vanish with them, and the new elements have nothing attached. Your delete buttons silently stop working after the first re-render. The fix is event delegation: attach one listener to the parent container that never gets wiped. Clicks bubble up to it, and you check event.target to see what was clicked. To know which to-do was clicked, you stamp each element with a data attribute when you render, data_id equals the to-do's ID. Then in the single container listener, const id equals event.target.dataset.id. One handler, one listener, and it survives every re-render because the container itself never gets rebuilt. No memory leaks from piling up orphan listeners, no broken buttons. This is the pattern you'll reach for in every framework-free UI you ever write. Let's stress test all 3 concepts with edit in place. Click a to-do, it becomes an input. You change the text, hit enter, and here's the subtle part. When you toggle or edit, grab a fresh copy with structured clone before mutating, so you're not accidentally sharing a reference with something else in memory. Update the array, call save, call render. Watch it flow: state mutates, persists, repaints. Refresh, the edit is still there. Memory, storage, DOM, all in lockstep. Day 14 done. The takeaway: your array is the truth, local storage is the memory between sessions, and the DOM is just a reflection you redraw with render. Stop reading from the DOM and your bugs evaporate. Subscribe for day 15, where we take this state-driven mindset and build a filterable, searchable list.